So welcome to our reference table quick videos. Today we are going to be looking at table I, which is the heats of reaction at 101.3 kilopascals and 298 Kelvin. So I underlined, or highlighted, the 101.3 kilopascals and 298 Kelvin, because sometimes a question is going to ask about a reaction, and it's not going to tell you to go to table I. It's just going to use that 101.3 kilopascals and 298 Kelvin. And you're supposed to know that you're going to need to go to table I. This is where matching something from the question to anything in the reference table, including the titles, is going to help you when you get stuck on a question. All right, so our quick overview, the heat of reaction is going to be basically heat absorbed or heat released in any chemical, and then we have a couple of physical processes down at the bottom. All right, so we have some values, we have some negatives, and we have some positives. But I want to make sure that we read the fine print at the bottom. So the delta H values are based on molar quantities, right? So the mole is our measurement that we use in chemistry. And if I double the amount of moles of a substance, and I'll get to that in a second, I need to double the amount of heat. A minus sign indicates an exothermic reaction. So exo, the prefix exo means out, right? EX, exit, out, means heat is released. And that means that the surroundings are going to get warmer. So for example, the temperature would get warmer. The minus sign indicates the direction of heat. It doesn't indicate a negative value. So if I look over here at this 91.8 and this minus 84, right? So you might think that minus 84 is a larger number, so more heat. That's not the case. The minus sign just indicates that the heat is going out. So in this case, 91.8 kilojoules of energy is going out versus 84 kilojoules of energy going out. So this one has more heat released because it's got the larger number. So the positives and negatives are just directions, right? Because chemistry likes to use symbols and shorthand, and we don't want to use words whenever we can. All right, so down over here, I just want to point out that when you get to the acid-base unit, the H plus is your acid ion, and your OH minus is the base ion, right? And so then this is your, and I didn't write this down here ahead, this is basically neutralization. So neutralize, right? This is why water is neutral, because it has an equal amount of H plus and OH minus, which we'll get to in our acid-base unit. So over here in blue, in this bracket, these are dissolving, right? So that's why we have this H2O written over the arrow. And so when ionic compounds dissolve, they split into ions. So that's why we call them electrolytes. That means they conduct electricity due to the mobile ions. All right, let's go back up here to the top. All right, so up at the top, we have some combustion reactions. And I know they're combustion because I have a carbon-containing compound, right? I've got these hydrocarbons. And combining with oxygen, we know that fire requires oxygen to burn. And we produce carbon dioxide and water as the only products. So these are true combustion reactions. And as you'll notice, they're all exothermic, right? When you burn something, heat is released, right? You feel warmer. So what did I mean about those molar quantities? So if I take a look over here, and let me go to my highlight over here. So if I take a look at this reaction right here, so carbon plus oxygen produces carbon dioxide, and it is exothermic, releasing 393.5 kilojoules of energy. If I have 2 moles of carbon dioxide produced, that means I have to double the amount of heat, right? So 2 times 393.5. If I only produce a half, I would divide that by 2. Does that make sense? Right, so it's like you double the recipe, you double the amount of product. If I have the recipe, I have the amount of product. And in this case, the product of those heats released. Most chemical reactions can be read in the forward, left to right, and in the reverse. So if it is exothermic, negative value in the forward direction, left to right, if I read it in reverse, it's going to be endothermic, and then the sign would be a positive sign instead of a negative sign, right? So an endothermic would be positive sign. And then in this case, this is endothermic because it's a positive sign. So if I read it in reverse, it would be exothermic and a negative sign.